I was the only person in my coding class who had never written a line of code. I actually quit because I thought I wasn't smart enough. Fast forward to 2026. The lowest I make is $227,500 a year as an AI ML engineer. Apple, Meta, Netflix, Amazon, they all reached out to me personally to hire me. Even during all the tech layoffs, I've got the job invite email sitting in my inbox. I'm not saying this to brag. I'm saying this because I want you to see what's possible. This video is everything that happened in between. The real path, not the polished version. The failures, the pivots, the moments that actually changed my trajectory. Consider it a roadmap from someone who's already walked the path you're trying to figure out. I'm making this because I know what it's like to feel stuck and not see a way forward. Doubting yourself and what's possible for you? If that's you right now, pay attention. Let's go. I want to start off by addressing the problem, or I see the gap currently in the industry. Now, most people think to get a 200K salary in AI roles right now, you require a PhD. You have to go to like Stanford University and have like 10 years worth of experience. Now, that's probably because the old path, 10 years ago, the only way to get into AI or ML, machine learning, was actually the researcher path. And yes, at that, most likely you're going to be in academia. So getting a PhD or having a master's level, publishing papers, actually designing models from scratch and training them, that was the path forward. But the thing is, nowadays, you don't necessarily need 10 years of experience because all of these models exist. There's workflows that actually work. AI engineering is basically software engineering just using AI models now. So if you're actually able to solve a problem, you are actually useful and attractive to companies. You don't necessarily have to be a researcher to get AI roles, though that is still a viable path, but you don't necessarily have to go that path. You don't need a PhD, you don't need a master's to solve real problems. The real barrier, however, is following the wrong roadmap, because you go on YouTube videos, watch certain path, or like learn how to write basically a character recognition model, and you're like, okay, now could I get an AI job? And that's not necessarily the right way to do it, because what could happen? Yes, there's a lot of information out there, but you could go down tutorial hell, right? Try to learn everything, applying absolutely nothing. And if you think about it, even before YouTube, it still happens still today. We actually have libraries, right? The thing is, people go to university or go to school specifically to get guided by a professor or someone who have worked or have done this stuff beforehand to tell you exactly which books to read or what, not even the entire book, just the exact examples you need to know to solve the problem that you're doing for that class. If you didn't have that, libraries are free. You could go into any library right now, go into a university as long as security doesn't stop you. In general, you could go into the libraries for free and you have access to all the books that are available that you use during class, right? But you're going to go down a rabbit hole because you're going to try to learn everything if you don't have a curated path to someone showing you what you need to do. And what you're seeing right now is you're watching people with a lot less experience get ahead because they're not trying to learn everything that intuitively that's what you're trying to do. You just try to keep learning and learning and learning. But if you don't apply anything at all, it's not really worth much. Whereas people are getting ahead, they might know a little bit of things, but they apply it and actually solve a certain problem. And that is what's interesting to companies. So the thing is, nobody actually tells you what actually moves the needle forward on your actual salary. You might see things on AI roles or whatnot, but you need to know exactly what you need to do to increase your salary. Let's look at reframing how we think about this. First of all, nowadays, 200K isn't about being a researcher. Again, that's still a viable path, and getting a master's or a PhD, that's going down this path. But you can make this type of salary in AI as an AI engineer. It's about being able to build and solve problems for a company and their business needs or their business problems. If you're able to solve that, you're valuable to the company. And here's the thing, your existing skills are the foundation because you already know the industry that you're in. You know the pain points, the problems, you know the solutions that you would like to see that would greatly exponentially help certain aspects of that business, the job you've done, the job executives do, or other people of the company. And if you're able to solve that, that'll be very valuable because you already work in that space. AI is just a multiplier of that. It allows you to do things that you weren't able to do before. So your domain experience is your superpower. And that's how you differentiate yourself from everybody else. That's how you become the signal from the noise, because even if I know AI, I don't know your domain as well. If you know AI plus you know your domain, you're a lot more attractive to companies who are hiring, who are able to solve in that domain space. Companies pay for people who can translate business problems into AI solutions. It's kind of like if you go to a mechanic, you know there's something wrong with your car, you're trying to get some maintenance. You basically giving your car and they be able to translate what's wrong with it, but you don't want to become a mechanic yourself. You just want to know, okay, what's wrong with it, give recommendations, and for them to interpret what the problem is and give you recommendations of what you should do next. And based off of that, you make your decision. You don't want to go to school to become a mechanic just to understand how the car works. You just want that mechanic to translate the problem to you so you can make an informed decision and move forward. The same thing as you working as an AI engineer is that you want to do that same thing for companies, is that you're able to translate the business problems into AI solutions so they can make informed decisions or basically empower their current workflow or tools to get a lot better or a lot more efficient or optimized output out of it, right? And one thing I would like to add, learning just in time beats learning everything, which I had mentioned earlier, where you don't go down the rabbit hole, try to learn every little thing. In fact, it's not, I would recommend against it because things change so fast. You want to be able to know what is relevant now because you could learn something that has been working for years and then all of a sudden something came and it just flipped everything on its head. In 2017, the transformer model architecture changed the way we approach things, and now that's like the dominating model architecture that's used that caused what we call the AI revolution at the moment. And it's very important to understand that is that even if you learn everything, all that was thrown out the window because this new thing is now dominating, right? So it's better to learn just in time, figure out what's working now to solve, have AI solutions for the business problems that you want to solve so you could get a much higher salary. I want to go over my path, my actual timeline to give you an idea of how I got into it. So my starting point in my AI ML journey around 2014, 2015. Well, no computer science degree, no tech background specifically in AI, ML specifically in that. I was in the 3D and film animation space, and I kind of encountered it because we're starting to see there's certain solutions that could be applied AI that AI could be applied to such big data and actually solve the problem. So that's how I was introduced to it. And just to let you know, when I started in tech or coding, my first coding class, I was the only one who never coded before. I guess people took it in school. I didn't even have access to that. In fact, during my high school years, I didn't have a computer at all. This is years ago. I know probably this newer generation can't even fathom that. The 3-year-olds are growing up with an iPad. But during when I had school, I actually had to do all our essays in paper and pen, and I literally didn't have a computer, so I only actually learned about computers after high school. So I guess that's probably why I was different than everyone else when I did my first coding class because I never ever coded before. So I quit when I first started because I felt I wasn't smart enough because everyone already knew these concepts, right? But that led me to go in and say, okay, well, I don't think people are necessarily smarter than me. They just have information or a leg up that I didn't have access to. So what is it that they have that I don't have? And I started off with like, okay, well, they knew the foundational things, right? Because they encountered it before. You can't blame yourself for not knowing something if you never even encounter it, right? So I went back to learn the foundation. So I started with web development for about 3 or 4 months, mainly because that's most universal. That is that technology kind of lasts for during the generations, the web has always been around in the 90s and the 2000s and up until now. It evolved, but that technology has been around, right? And then I started learning Python because that started becoming popular. Before that, people were talking about C, then C++, then Java was around for a while, then C Sharp and JavaScripts and things like that. But then Python started becoming more popular in the sense that it's an easy enough language, it's general purpose, and it's easy. It is powerful, right? And a lot of main industries, especially in the film and 3D animation industries, Python is kind of like the main glue software, say, main glue language as a de facto to work with. And then if you need something a little more specialized, then you start deviating. But it's kind of like the fallback to it, right? And because of that, I learned because, like I said, is encountered in my industry, and when you start learning the foundational coding, a lot of things started using Python. I never actually learned Python from classes. It was just so I didn't really learn it from any courses really. It was just by doing it, by doing the examples that I encounter, especially when working professionally. A lot of solutions were in Python, so I kind of picked up by using it. It's similar to as if you went to a new country and if you're there for like 2 weeks, you start picking up the language, even though you never officially learned the language. Or if you think of infants or toddlers, they learn their native tongue, let's say English, just by being in the environment. They're not born and then you put them in class and you teach them all the syntax and how to read a dictionary and everything like that. They pick it up by using it. That's kind of how I learned. Now, the thing about that is, of course, it's not optimal. So, of course, when you show other people that who know how to do this when you started out, you might have, I guess, this imposter syndrome, right? Because you're like, oh, I don't know if this is not the proper way you do things. However, I started getting noticed because even though my solution may not have been optimal, it actually got the job done, which is better than people's, perfect optimal solution that doesn't exist. So you'll notice this that people might critique you on how they would do something better, or you should have done that. Being a critic in general is the easiest thing in the world because you could just pretty much give your opinion without any repercussions, or even have to prove that you have to do anything, right? But at the end of the day, even if it could be done better, the fact is the work you've done exists and can be used, whereas the perfect solution doesn't exist, right? So who do you think who do you think they're going to pick at the end of the day, right? And if you do this continually, when your non-optimal solution will actually get better, and as you learn, you'll start becoming more optimal, but also too, you're gonna actually start getting recognized because you're able to get the job done. That's in general how it works. And this is where you might still get critiques or critics telling you, or quote unquote haters saying like, "Oh, this is not good," or say why things wouldn't work. But it doesn't matter if you're actually delivering on what you say you could do, right? And once I learned the foundational things here, that's when I started transitioning more into AI, because the AI did build on these foundational stuff in terms of web development. A lot of the deployment used back end, front end, and Python was used for a lot of the back end. Python was used to actually for the model frameworks. Actually, even back then, you actually had to code your model from scratch. But then frameworks like TensorFlow and PyTorch came around, so that worked. And actually, my first AI job was actually making prediction models for the stock market. And you would think, okay, well, I've never worked in this before, but I had the ability to at that back then to translate research paper to actually working code because I've been doing it during these foundational stages and actually working on real projects while I was working in the film and 3D industry, right? So the job I got, maybe it was an entry level, even though quote unquote I haven't had experience in the stock market space before. But I got headhunted because at the end of the day, going back to your non-optimal solution that gets the job done versus the perfect theoretical solution that doesn't exist, few people could actually do it. And this is why you get headhunted, because at the end, we're like, hey, this person can actually get the job done. That is what recruiters that are companies are looking for. They want proof that you're able to actually do it. And then optimization will come over time. Get it to work first, then we'll optimize, as opposed to get it perfect and never actually do anything at all. Nothing actually come out of it. It doesn't exist, right? Then once I started seeing, okay, well, there's actual traction. I saw even 10 years ago, and companies are hinting at this for a while that they're going to go for automation. They're going to go for AI. They would show it basically in their all hands meetings every quarter when they're basically explaining what the future of the company will be, and they'll show their projections for the next 5 years, and they would show that productivity goes up, but human resources, or now they call it people relations, I guess, for the name, would go down. And how are they going to scale up this productivity through automation? Basically, they're saying AI back then. That was like 10 years ago. Now we're seeing the results of that. And 10 years ago, I was seeing that that's the path that every company was going for. They're actually actively trying to get there. So even when people are saying AI came out of nowhere, no, companies were actually actively trying to do this prior. You're only seeing the results of it now. right? So during that time period, seeing that that's going to be the future, I said I should really invest in AI and make sure I know about it. Whether you agree with it or not, it's going to be the future. How can I benefit from that? So I started looking for mentorship for people who are authority in this space. And this was around 2019. So I sought out Yoshia Benjon, who, if you don't know, is the godfather of AI. He is the most quoted or most cited researcher in the AI space in the world for this. One of the three godfathers of AI. He actually has like an interview on a diary of the CEO recently of it, and learning directly from him. In fact, he was actually advocating for like this deep learning approach because the concept of this has been around like since the 70s. It's only more recent years that we're actually able to do it because of, well, quite frankly, video games. Because of the GPU, we're able to process large amount of data and actually calculate all them in a meaningful way. So that all these algorithms that existed before, we couldn't prove it before. We just didn't have the computation power or the memory. Now we do. And once you start applying and you're seeing that this new approach that has been proposed for decades now is viable, it was greatly outperforming the classical AI approaches. That when I say AI are classical algorithms, because the term AI is used now, but that's a certain subset of a technique we're using. But we've been using AI all this time. It's just using classical algorithms. A lot of it was just like if statements or heuristics or predefined notions. Whereas how it is now is that you pretty much give it a bunch of inputs and say, this is the results of these inputs, learn what the pattern is. So you're basically letting the the computer learn the patterns itself as opposed to you coding it. That's the main difference between how we're doing it now versus how we did it in the past. And it just takes a lot of computation time to do all this stuff, right? So to learn this from someone who's been actively doing this for their career and known for it, I said I had to learn from someone to jumpstart my, I learned the foundations for 3 or 4 months. I can't spend decades just trying to catch up to the state of the art. When you're learning, what I say is when you're learning something new, when you're breaking into like something brand new over here, you want to learn from people who've already done it because they already have the shortcut. You can go in and try to solve the maze and spend all this time. You could be stuck in a maze and they could spend years trying to get out of the maze. But the thing is, once you know the maze, you could just give that map to anybody and they'll go get out of it right away. So learn from someone who already done it and let them teach you. So your starting point is where they ended. And all that time you would have learned to get to where they are, you could use that to actually further yourself, right? And the thing is about this, once you start being in this space, you start networking and other people start noticing you. And I was able to network with Kat Menelak, which is from Y Combinator. If you don't know Y Combinator, if you've heard of like Twitch or Stripe, this is the biggest accelerator in the world that created these companies, right? And also Michelle Zadlan from the Cloudflare CEO, self-made billionaire. Everyone, if you're working on a computer and ever been to a website, and he said, you know, you've been using Cloudflare behind the scenes, and you start being in the space, you start being around the same, very similar people, and it starts being perpetuated, and that's where opportunities are created. Because by networking, people say, "Oh, you got lucky." Well, luck is when preparedness meets opportunity. So the preparedness was working on all these foundations, learning from the best in the industry of this, right? And then networking, putting yourself out there to have these opportunities come up. And then when the opportunities come up and which is here when you network and then you're prepared, that's when you get lucky. But that translates to being headhunted or it's not by accident people go and find you or things line up for you. It's by orchestration, it's by design. And that's you doing active active or I would say concise or planned with intention um, uh, jobs or things that you want to do. Like you're actually doing certain actions to line these things up so you could actually take advantage of it, right? So after this mentorship, like now, if we fast forward to like 2025, and I've done this for a while, this is where I see it. Okay, I built a system around how you could getting hired and how you get high paying AI roles. now that it's starting to blow up because I was getting reached out, people are reaching out to me, and I mentoring people that came up. They said like, "Hey, I just finished my tech um, internship, or I did my degree, or I learned this is what I'm doing in my current space, or I'm trying to get into this. How do I actually apply for a job, especially in this climate where a lot of times um, people are applying, but they're not hiring people in the software industry. In fact, recruiters or jobs you used to be able to connect with them, and now you have to like kind of subscribe and you get ghosted, right? But how is it possible that now in that climate that people are still there's still headhunters, there's still people looking for people who can actually get the job done when there's thousands of people applying? Well, the main thing is that they want to know that they are actually looking for people. They want actual talented people. But now AI is such a big buzzword right now that everyone claims they could do it, and they're getting like thousands of applicants. So you're getting a lot of noise, but most of the people can't actually solve their business needs. You want to be able to demonstrate that you're able to do that. Hence, why I personally got like mentored by the people the best in the industry and actually did real projects to show that I worked at real companies. I've worked on with real people, and I know what how to actually take an AI solution and apply it to a business problem. That's what, and I've been able to prove that. So I'm been mentoring people of how you actually could do that, map your actual skills to a business problem, and how to get people to or these companies actually to come out and reach out to you. And it's worked in the past. And recently, I have Meta reached out, Reality Labs for the research roles. Apple reached out for AR, VR technology roles. Even Netflix reached out for animation roles, and it actually does work when they are aware of what you could do. And they know of your past, and you know that you could actually map an AI solution to their business problem, right? And the result, if you look at like now, like 2026, like an annual salary of like 227,500 is kind of like more of like the range you could start looking into prior to actually start applying to your own specific needs, because yes, you can get much higher for that, but I want to be realistic with that because that's going to depend on your other skills that you bring to the table. For example, going to these type of companies, Apple, if you're doing AR, VR research, they're looking for a certain skill set that even if you know AI, you know this space as well, right? So that's going to affect your salary. Same thing for meta research. Not everyone is on the research side of things, and animation that's like 3D. But the whole idea about that is that there's many divisions of this. AI is kind of the baseline, but I'm just trying to give an idea of kind of like the baseline what you could expect, and it could go up from there depending on your domain. And this is why your domain expertise, and this is why I was saying like your domain's your superpowers, because the more specialized, the more skilled you could actually translate your own experience into that. This you could make yourself a lot more valuable than the base salary, right? And especially when you have that, FANGs companies would reach out to that if you're at that level as well. Um, that's what happened to me, and I not only that, I actually worked on projects that got patents. So I actually have over 20 patents. Um, and these are all verifiable. So companies go in, they'll search my name, and then they'll see all the patents. And past work for notable companies, I've built AI for Apple Vision Pro, and also I built self-driving cars, so we actually could see an end result working live. There's no real denying that. So like, okay, you proved you could actually get the job done. So we could start discussing. And I just like to mention afterwards, I did actually get a computer science degree and graduated with honors. But this was after I already started working with AI. In about like 5 years of already working with AI about that. And the reason I got that, it's mainly kind of like to say like I already knew it. But however, to tell you the truth, that didn't really, for all the AI jobs, that didn't matter at all for like AI engineering jobs. The only time like the degree matters are like more for the research type jobs, right? And that that's a very different space. That's actually like creating new models and creating the state of the art for the future. Whereas a lot of AI engineering job is basically a software engineer. You just said you're using AI models. You're not expected. to actually create new models, or even train them, because nowadays models already exist. So your main goal is actually to have a solution for the business problem and put it all together and make it work. I think of it as very similar to like a computer technician, someone who knows all like the computer parts. And if you ask them, I want to build this type of computer, they could build it for you. But they're not like a computer engineer or a researcher where they'll actually go and design a new chip or a new GPU that the company would never seen that's faster than out there and then build it out and make it from scratch. No, they're going to look at things that's already on the market, put it together, and actually solve the need that you want because you want to go and play the latest video game, for example, that uses the highest spec or something like that, right? So they'll know how to make that happen. You're doing the same thing as an AI engineer. You know all the tools that are out there as a software engineer, for example, but you're also aware of the AI models and how to put that together to get the result that they want. And the thing about this is that most companies are that are looking for AI are not AI companies. They're not tech companies. They're just regular run-of-the-mill businesses, but they have decades worth of data of like past clients or customers or information of their business that they want to consolidate or have quick ways to access to it. And they know AI can do all that work. They just don't know how to use it, but it will have a great impact because if they have to hire someone manually to, let's say, do ad data entry, and they have to pay them a certain salary for years, and it takes a certain amount of time to do it. If they could build all that and everything's instantaneous and is connected by AI, that's super valuable to them. And they're not a tech company, so there's a lot of opportunities out there for that you don't need a degree to use to actually apply for, unless you're doing like research or whatnot. But a lot of AI jobs are not that. Here's some advice that I would like to offer you that if you want to actually start learning on your own how to actually get into this space, here are the key skills that I would suggest that you make sure you learn, that you basically bridge the gap that's needed to actually do an AI engineering job and not go down a rabbit hole of just learning, let's say 100 days of Python coding. Not that there's anything wrong with that. That's fine. But if you're trying to solve a problem specifically for like AI, here are the things that I would say that you need to know to actually get the job done. So the first thing, you have to have the ability to do data manipulation, and the standard tools that you would use in this day and age is, well, now Python is kind of like the de facto language used. Yes, you could actually use absolutely any language to do machine learning or AI or deep learning and things like that. But research paper and kind of like the de facto is go to Python and use these libraries. And first part is actually manipulating the data. And so you should learn these libraries, NumPy, which is numerical Python. That is actually to deal with big numbers, big data, and crunch those numbers efficiently. A lot of people say, well, Python is slow compared to, let's say, C or C++. Well, NumPy is a module in Python that is actually built on like C and actually makes it fast enough for it. And then on top of that, there's Pandas, which is built on top of NumPy, which is basically, think of it as that you could ingest like Excel sheets, like Microsoft Excel sheets or Google Sheets, or export them as CSV or basically comma separated values and process them in a lot more efficient way. And then the other one is Matplotlib, which is, and also Seaborn. That's another one that is built on top of Matplotlib. And that is to visualize the data. And this is very important because at the end of the day, you want to be able to explain the data and give the interpretation of that to people who are not data scientists, who are not AI engineers, who are not technical, and make them understand. Think of it as like the mechanic explaining to you what's wrong with your car, right? You're not a mechanic. You don't want to go to school to become a mechanic, but you want to be able to understand that and be able to visualize and show them the impact is going to be a lot more meaningful. And having that skill is very important to communicate that. Honestly, data manipulation, you should master this because 80% of the real AI work is that. Because when you look at it, algorithms or model architectures, when you start a new model, if you're creating it from scratch, a lot of times you're just using it. It already exists. You just take one that already works, that's very similar, and you just build it, and then you put the data and let it do its magic until it converges to a solution, right? That happens a lot of times, even if it's not AI, just algorithms itself. The algorithm itself is actually pretty simple. A lot of times it could be just one line of code, but preparing the data, doing all the overhead to get everything set up, to communicate, getting curating the data, processing it, then dispersing it, and how do you deal with a lot of people accessing it, and you don't have clashes. That's where a lot of the work is. But mainly the data is the oil. That's the one that's the value. That's where all the 80% of the real work is, because you want to make sure that it's working properly. So that's the first thing. Second thing I would say is actually learn classical like ML and classical ML like machine learning and classical algorithms like statistical models first, right? That's why I would say the next Python module or Python package to learn is scikit-learn, because it does do machine learning, the basic neural networks. It also comes with a lot of like statistical models or arithmetic models that are you don't have to implement. Let's say linear regression or trying to find like the coefficients of numbers if you're given final results. These things that you would do by hand on paper that are used are still actually useful today. In fact, most problems, especially if you're like I mentioned before, a lot of companies that are looking for AI engineers are not necessarily AI companies itself or tech companies. So when you think that, you think you're going to be using these. What do you think AI engineer? You're thinking you're doing the most advanced, state of the art, cutting edge tools that exist. But most business cases, they'll pay you a lot of money to actually solve the problem. And the problem can be solved with just classical statistical models like linear regression. Linear regression works all really, really well. Like if you're not familiar with that concept, but like let's say you have a graph and then there's like, some value that they map here on their x-axis and another dependency on the y here. This could be like, I don't know how many customers they have and how much they're engaged or whatever. And you see a lot of data points like this all over the place, right? Maybe not those long lines, but like just points like this. Well, linear regression is trying to find a line that best fits most of the data, that reduces the distance from here, from the line to the point. Why? Because now you have an algorithm or a model that if I say what if the value here, it will go here and give you an estimate, and that might be close enough within that data point that it actually outputs something that's useful to you for the business. Is close enough. This is linear regression. This is a standard statistical model, and it works a lot in a lot of cases and makes your job easier. They still pay you a lot of money because you used AI to solve the problem, right? But main thing about that is even if it doesn't work well, before you start going into anything complicated or any complicated machine learning models, you would still use this first and see what the results give you. And if you see that the results are not good enough, at least you establish a baseline before you're going complex, because you're like, okay, I've done that. Now I see that the simple models, classical stuff doesn't work as well. Now let's bring out the heavy guns. Let's do the heavy duty stuff. And that's when you start going into like deep learning frameworks and you start looking at what are the state of the art. Let's look at PyTorch. Again, this is inside a package inside Python. And this is created by Facebook. That's the de facto deep learning framework that most models you'll see that are out there. And even if it isn't, there are ways to convert from other packages. Like there's up to convert a model architecture, like using, for example, the ONNX converter, like into ONNX framework, where you could convert it to that, then convert it to another space. I've done that multiple times where something was trained, let's say in TensorFlow, and well, we're doing it in PyTorch now. So we take the model architecture, convert it to ONNX, and then convert it back to like the format for PyTorch, and then you put on the weights and train all that. The other thing I would say is learn the transformer architecture. Basically, you look up the paper. If you go to Google and Google the word Google Scholar, which is also a Google search engine, is from Google, but Google Scholar, the search engine, looks up papers for you. And look up the paper. All you need is attention. All you need is attention. That explains the transformer architecture that came around, I think, 2017. And that model architecture is kind of like what changed the world now, that made a lot of things possible. So learn the basics of that, but that's just when you start going to heavy duty, right? Next, especially this day and age, like 10 years ago, you had to, if you could use AI, what they call AI now, like supervised learning and whatnot, using TensorFlow or PyTorch, deep learning, that's what you had to do. You had to be like research level. You had to be strong in math and understand it, like calculus, statistics, linear algebra for like matrix multiplication, matrices and all that, matrix math. But after a decade, a lot of these models exist and you could just use them. So learning how to use, there's a lot of different like large LLMs or large language models, learning, and each one of them have their strengths and weaknesses because let's say a very powerful one might be really, really too big and you can't, you have to connect to a cloud. It's going to cost money to actually, or tokens to actually use it. But depending on your actual solution, you might want to use something that is more local model that you could run on your computer that's more environmentally friendly. Because if you could run a video game on your computer, on your laptop, you could run these models. So you want to be able to make those choices. And especially this day and age, knowing using like LangChain to get work with multiple LLMs, RAG, and agentic workflows is what greatly made these implementations useful to actual businesses. Because if the world, if you realize, or if you when ChatGPT came out and it was public facing, the world used it. It was great at first. People love it, but then they realized a lot of the answers were very generic. And if it didn't know something, you did not know that it did not know it because it started hallucinating and make up answers. Right now with like RAG and agentic workflows, plugging in you with RAG, you could actually plug in actual, let's say for a business, the actual business information. This is why data manipulation is one of the most important skill. Is a non-negotiable because if you're able to take the data from the company and use RAG to put it in, now these LLMs have the context of the company and can actually answer with respect to that instead of hallucinating things. And then agentic workflows, for example, a large language model was not necessarily trained to be good at math. You'll find out it could make these really intricate essays and write it in different styles. But if you give it like a word problem of like if Johnny walked down, he had two apples, and then Sally came and took one away, how many apples are left? Sometimes the LLM might actually say like 20 or something like that. And you're like, how can you get something so simple wrong? Well, with agentic workflows, it could actually fill the gap because again, large language models were not trained specifically on complex mathematics or something like that, right? Unless it was trained for that specifically, but a lot of times they're not. But with agentic workflow, it could say like, hey, this is actually a complicated math problem that I don't know how to do. Instead of be training a model to actually take that as well, which some research papers have shown that actually makes the large language models perform worse. What they do instead is you don't even bother, is that I'm not good at doing math. However, I know how to implement, I could use agentic workflow. I could actually implement an application such as Python and put the information in Python, let it calculate it and give it back to me. And I'll use the answer in my solution. So agentic workflow now gives it abilities that the models weren't trained to do, but it actually gives it the tools to get the results they want and actually put it in, right? Like OCR, like optical like character recognition. You could take a picture of a page and you could use that agentic workflow to get all the characters, and then now I could actually read it. Now you could put it to LLM. So that's knowing how to do all this stuff. That's where the jobs are right now, right? Now, once you have that skills, then you have to actually have like the engineering and the deployment skills. This is common like software engineering or DevOps type stuff, right? To work in a professional capacity, know Git for source control, Docker, so you could actually containerize all the tools you've built and avoid the problem of, well, it works on my computer, but when you try to set it up on someone else's computer, it doesn't work. And then also the cloud basics like AWS and whatnot, how you could take your containerized Docker or information, deploy it on the cloud and scale it up and actually make it work, right? This part is why a lot of companies, or when, a lot of companies are getting people who are applying for their jobs for AI positions, like thousands of them, they don't even get a callback, is because this part is what separates a hobbyist from someone who hires, because they're like, hey, you actually know how to build a model that works, but actually deploy it and actually maintain that in a real capacity of like a professional capacity. That's what's important. And this is the part that I see skipped the most. I haven't seen any tutorials really on this. If they ever talk about AI or whatnot, actually, there's very few things I even seen talk about this at all. And that is basically over here, the business translation. In fact, I wrote a book on that specifically because it astounds me how still this is like a skipped a skipped skill that is actually the bridge between the two. How do you take all the technical stuff and explain it to non-technical people? How do you explain AI to non-technical people, right? Literally, this is the difference between a 100K salary and a 250K salary, because you're able to do all these complicated things, which nobody cares about linear regression behind the scenes. They don't know what it is. They just want to know when I give this answer X, it makes a prediction for Y over here, and it gives me a good result, right? And you want to be able to explain this to non-technical people so they could understand it enough to make a decision. So you could interpret it for them and make a decision, right? And you might want to visualize it. This is why you want to learn like Matplotlib or Seaborn here to visualize it to for people who to understand or get it. Like, okay, I get what's going on. Now I understand. Let's make this decision in confidence and move forward. And especially if it works out, you are in their good graces, and that's where like promotions and bonuses start becoming part of the conversation. I feel it's important to actually talk about mindset and how the mindset shifted for me because I've been there from that point of view, and you're thinking you can't do this, and this is way overwhelming for you. But I got in from a space when I started out. I literally didn't have a computer all of high school, and then I learned computers late afterwards. And then when I did coding classes, I was the only one in the class that didn't know how to code at all because everyone did it. And now today I have over 20 patents. I have a book written on it, and I've worked now in AI. Again, another thing that I jumped into that didn't know of it. Got, of course, people critique you saying like this is not optimal and whatnot, but that's exactly why you should do it, because how you're going to get better unless you do it itself by doing it yourself. And the more you're doing and the more you solve problems, the more attention or more people pay attention to you, right? And then was able to connect with industry giants in this space. So Yoshia Bengio, I mentioned the CEO of Cloudflare, as well as I commented as well, just by doing it. So the best way to actually go over something or get better at something that you're not good at is actually doing it, right? And I actually had this in the opening of my book that again is on Amazon. The first line I wrote in there is that complexity is just compounded simplicity, right? When you don't know something, of course it's complex, right? But when you actually break it down and you learn each piece individually and you realize the complicated thing was just the simple things just combined together, then you actually like, oh, this is actually manageable. And I found that with everything. If I don't understand something, I'm like, okay, let me break it down. What's the foundations things? Most likely I don't understand it because I don't actually understand the foundational parts that make it work. So let me understand the foundations. Now I understand that, okay, how do they work together? All right, what's the problem they're trying to solve? What's the goal? Then I can actually understand the problem at the end, or I understand how something works, or how understand how something complex works, right? And this leads to the next thing. Clarity in your head actually beats cleverness in your code. In fact, this approach or this mantra is actually if you're going to work in the AI ML space, you're going to see this term called literate programming. That's an E, literate programming. What that is, it's a shift where the code itself is you're actually writing more of the explanation or the thought process first, then actually have the code reflect that, as opposed to the problem I always had, like especially when I was coding for all these years, and why it was so complex to me is that you look at code and they're doing all these little tricks, and if you're using Python, they're they want to write Pythonic things. They want to use like list comprehension because it's a lot more efficient than if you did like loops and all that, which is fine and all that. But if you never did code before and you're seeing all these tricks and these shortcuts and you don't understand what they're saying, or they have variable names that are just one letter or shortcuts, you don't understand what's happening. You're more caught up with like just trying to understand what the code's trying to do, as opposed to what is the main idea of the clarity of what the whole system's trying to accomplish as a head. And literate programming is a move forward that in the AI community, AI ML community have adopted it. And one of the proponents of that is actually using like Jupyter notebooks or Jupyter Labs, basically think of it as a research paper where the code or the equations in there is actually executable. So it's meant for you to actually look at and be able to read the explanation as if you're reading the textbook, but the actual equation that they show there actually could execute. So you understand what's happening and actually make it work. The whole idea is to have clarity. And this is why I would think that there's such a huge boom in AI industry or ML in the academic world or in AI, the world in itself now, especially now commercially, because it's being used commercially now, is because of this approach where you're actually making coding understandable so anyone can understand it. And then once you understand it, then you can put it in any language really. But the main idea is to actually communicate and get the concept across, make it clear to a person, as opposed to have just clever code to show how smart you are because you know how efficient you are at coding, right? The other thing I definitely learned is your best work is your finished work because when you start something at the very beginning, you're going to be terrible at it. It's inevitable. No one hits a home run on their first swing. You're going to be bad. It's going to be laughable. People probably will laugh at you if you showed and all that. But like I said before, your best work is your finished work compared to a lot of people are just afraid to fail or to look bad, so they never do it. But they'll critique how they would say like the perfectionist, so that's why they don't do any work because they don't want to show any weaknesses or anything that shows that they're not in their best optimal light. Now that's actually detrimental to you because that means you never actually finish anything because you always try to make it perfect. But your finished work is your best work because at least it's something working. And maybe not be optimal, but it's actually something working. You could use as a baseline and say, okay, I learned from this because this literally links to this one where failure gives your data, where you make something and it might not, like I said, your first tries are going to be terrible in anything you do, right? So you learn, you do it, it didn't turn out how you expected, but it's not a failure. Failure is actually data saying, okay, well, like I said, it's a baseline. This is what I wanted to do. This is what I expected, but it fell short. Why did it fall short? That's your data. Okay, what do I need to do to improve it for the next time? And then you try again. And then, okay, you choose at least one thing to improve and see if you get better results. And incrementally, if you improve those small things, you go from terrible to great after, right? And that's where your confidence builds because confidence actually comes from competence, right? People don't feel confident because they haven't done something. So do it. Go out there and start doing it. Get your reps in, make a lot of failures, make your correction, and then you start making less failures and you start becoming a lot more competent at what you're doing. Once you're competent and once you know you've done something because you've done it before, you're extremely confident of it, right? So go out and do it. And if it didn't work out, it's not a failure. Learn from it, get the data and try again until you're competent at it, until you're confident at it. I just want to expand a little bit more on the confidence comes from competence part, right? Because again, everyone goes through this. When I started, for example, I didn't have a computer science degree to learn AI or whatnot, right? I didn't have one at all when I started. I got one after, like 5 years later, to say that I knew it. But honestly, the degree itself, I didn't actually learn from the degree, the entire degree itself. Every one of the classes I've done it before in real world scenarios. In fact, a lot of it, some of them, I really just retook some of the things I did before and just like submitted that for my own personal projects or my own personal learning, and it worked, right? So, so the degree thing, you don't need a degree, especially nowadays, to be an AI engineer. Again, if you're trying to do a researcher or yeah, in that space, a PhD and a master degree might be something they'll be looking for, mainly because of that's academia, that's how it works. But to be an AI engineer, if you're a software engineer, an AI engineer is really a software engineer just using AI solutions. And nowadays, you don't have to build the models; they already exist. You just use the frameworks, right? The other thing, you might not think you're smart enough. I literally felt that when I first started coding classes. I didn't have a computer until after high school, and I quit my first coding class because I'm like, I literally didn't belong here. Everyone knew this stuff, and I didn't. But when I thought about it, I'm like, no, they knew it because they encountered it before. So I just didn't have the foundational things. I had to go back and learn all the foundational topics, so I was able to actually to work with it, and now I'm way more comfortable in it. You can't say you're not smart enough something if you just haven't been exposed to it. So if you know what you need to do, and you do it, you'll be right up there with anyone else. So you never think that you're not smart enough of it. You just need to be exposed to it and actually get that leg up there yourself, right? Especially now, the problem you hear that the market is saturated. Well, it's saturated with like tutorial watchers. They're not necessarily qualified people, right? There are still headhunters. There still are recruiters that they are actively going out and reach out to people, be people who are actually able to build things, right? The market is not saturated for builders. And honestly, the number one thing I get that is told all the time when people reach out to me and I speak to them is that they say, yeah, we've been searching for a long time and it's hard to find someone because no one's able to do this. That's what they always say, right? That's what they're looking for. So it's not the market's saturated. The market's saturated with people who are underqualified in the sense of they just do tutorial things, but they're missing all the other stuff that I mentioned there, being able to take that, apply it to a business problem, specifically their business problem, being able to explain that to stakeholders, executives, or any other people, stakeholders using it as well, and also being able to communicate that in general to everyone else, and being able to having domain expertise, using you leverage your own expertise in that space to know what the problems are, know what the pain points are, know what the definition of success looks like, and how to actually translate that, right? Other thing is, I have no connections. Well, yeah, I built connections from zero because what happens, these are all related, right? The market is saturated, but if you start putting out things that to show that you're a builder, that you actually solve problems, people are going to notice and they start reaching out to you. That's how you build your network, right? The other thing is, it's too late for me. That is, I would say, the biggest thing because literally something new comes out every week. And nobody is permanently ahead. So someone that knows the last 10 years of like AI, ML model building and know how to build models from scratch, like I said, something just new comes out every week. You don't need to build models anymore, right? You could use LangChain and have LLMs, use LLMs and build things together. So that person that has all those knowledge and expert in calculus and statistics and linear algebra, right? That yeah, they might be able to do a researcher, but if they're doing AI job, right, those skill sets are not necessarily useful in in that context. So you're on equal footing at that point, right? So it's not too late. You have to be able to work with what's now, and everything's happening so fast that you just have to be able to use what is available now to get ahead.